What's good, my statisticians? This is Professor Sampson from PS I Love Math back with another statistical banger. Well, today we're going to finish our ending of those hypothesis testing, and we're going to end up at least with one sample hypothesis testing. But this one is a little different. We're going to be doing the chi-square test of association. Don't forget to like, comment, and subscribe, and let's get into this video right now. So, what is the chi-square test for association? It's a little bit different than our other tests that we've been performing because this one wants to determine whether two traits in a population are associated or are they not? Are they independent or are they dependent? And we use this often in real life to determine if two characteristics are dependent. Or is your age dependent on the color car you buy? Any of those. So that's what the chi-square test of association tells us. As you know, those two things are what? Are name only or nominal. But we do use the numbers, and the numbers that we use come from a chart. Now remember back in chapters 1 or the very beginning, we talked about frequency table. So the tables that's used in chi-square test is called a contingency table. It's a special form of frequency table where it compares two things. And we also need to go back in the day when we talked about expected value. The expected value is equal to the row total times the column total divided by n, which we know is the sample size. Now, we could do all these expected values by hand, but I will show you a method to do in the calculator. The next thing we want to do is the test statistic for chi-square. That's going to be chi-square is the sum of O minus E squared all over E, where we say O are the observed frequencies and E is what you would expect, the expected frequency. Again, some of you may be using this and getting this, doing it by hand because you're not allowed to use the calculator, but in here, we will use the calculator to find this. The last thing that we're going to need for our test of association, like any chi-square value, is going to be our degrees of freedom. So how do we find the degrees of freedom for chi-square? Find the degrees of freedom for a chi-square test of association. R minus 1, which is your rows minus 1, times C minus 1, which is your column. So R equals rows and C is equal to column. The degrees of freedom you'll actually have to find by hand. No calculator shortcut to get the degrees of freedom. For the hypothesis test, we still have our normal rejection region. So you're going to reject the null hypothesis. These are all right till, of course. Right? You're going to reject the null hypothesis. Of course, when your chi-square test statistics, right, is greater than or equal to your chi-square alpha. That's like when we drew the picture and we had our critical value. Anything to the right of that is going to be in our rejection region. So let's jump into our example. Your null, as you can see here, is going to be that the two variables in the population are independent, and your alternate is going to be the two variables of the population are not independent. Now they use are not independent, or you could use dependent. Suppose that a bookseller wants to study the relationship between book preference and residential area. A random sample of readers is chosen for the study, and each participant is asked to choose their favorite genre out of the following choices: mystery, fiction, nonfiction, and self-help. The results are detailed below. Does the evidence gathered show a relationship between book preference and residential area at alpha equals 0.005? So the first thing we're going to do is write our null. The null is going to be pretty simple, pretty straightforward. The two variables right here are going to be book preference and residential area. So that's what you're going to write for your null hypothesis, that book preference and residential area are independent. Your alternate is going to be book preference and residential area are not independent, or you can put dependent. We have our null and our alternate. Now we're going to go to our test statistics. So we're going to start off by putting this into our calculator, and where we need to go is a matrix because the data is always given in a table, and this table is called the matrix. So the matrix button is on top of the inverse operation, as you see x to the -1 right under math. So you hit second and then you can go to matrix. But we need to go over to edit to create this matrix. And we always want to create it in matrix A. So you hit enter at matrix A, and you're going to tell the size of a matrix. So I don't know if you know how to determine the size of a matrix, but let's check it out. A matrix is written using RC. So your matrix is written using R by C, the rows by the column. In this case, how many rows do you have? Rows, horizontal, I think of it like that going across. You have 2 rows. Don't use the total row. Then how many columns do you have? So 4 columns. This is going to be a 2 by 4. We're going to put a 2, and if you hit enter, it'll skip over to the column part in 4. You know if you got it wrong because you won't have enough or you'll have too many. So I'm just going to hit 28, and then you hit enter, and it'll jump and go across. Actually, we're going to do a hypothesis test. Remember, we're looking for our test statistic. So we're going to go back to stat. We're going to go over to test. If you go up, you're going to use the chi-square test. In my calculator, that's C, but you're going to use the chi-square test. Once you hit the chi-square test, you're going to hit enter. Leave everything alone. Your observed is in A. That's the stuff you put in. It's going to give you your expected value that we talked about, and you just need to go down to calculate. That it gives you your chi-square value and a p-value if you're going to be doing that method, which I'll demonstrate in a minute. But for now, we're looking for our chi-square test statistic, which is 10.418. Remember, we always do the same number as the table. Our test statistic is 10.418. We're going to do the critical value method. If you saw the other videos, it compares your critical value to your test statistic. So we're going to draw the picture. Always write tell for this. So we need to find our critical value. If we look back at the problem, our alpha was 0.005. And remember, we need our degrees of freedom to look this up. And our degrees of freedom, remember, we had a formula for degrees of freedom, R minus 1 times C minus 1. That's the degrees of freedom. So your degrees of freedom, in this case, our row was 2 and our column is 4. Our degrees of freedom, 3. So now that we have our degrees of freedom, we can look on our chi-square test for degrees of freedom and our alpha of 0.005. So here's our degrees of freedom here. And as we go over, we'll see our chi-square value here of 12.838. So our critical value is 12.838. And then we say, well, where does our test statistic fall? 10.418 would be, it's in our fail to reject region. So we're going to fail to reject this null hypothesis. So what's our interpretation for this? There is not sufficient evidence to support the claim that an association exists between book preference and residential area. So our test for association, remember, is trying to tell us, is there an association between these two things? So there either is or is not sufficient evidence to support that claim. So we're going to do the p-value method, p-value versus alpha. We have our alpha here to be 0.005. And if we go back to our calculator, we'll be able to see that the p-value is 0.0153. So we're going to fail to reject the null hypothesis. The last thing that I want to point out is another question is always, what's the expected value? Was to take the row total and the column total, multiply those two and divide it by n. It would look like this. Our chart rule would be the same, which is 121, and we would multiply that by a column total, which we see is 60, and we would divide that by the total number, which is 266. So 121 times 60 divided by 266, 27.293. And then you would have to do it for each one. And you would go through and keep doing that if you had to do it by hand. We're not going to do it by hand. So you will be asked expected value. So we're going to go back to our matrix. And remember before, I don't know if you recalled, I didn't say anything. When we first came here, there was nothing in B. Our calculator, when we actually did the test statistic, put things in B, which is the expected value. Now you can either go hit B or you can go over to edit. I like to go over to edit and then go down to B because that's where the expected values are. And you can see here, you can see the full chart. So you would copy this full expected value chart onto your paper. We're going to do one more. A marketing firm wants to know if there's an association between a person's age and level of education attainment and his or her favorite Super Bowl commercial. A random sample of people is asked to choose between 2 commercials and the results are in the following table. Given these results, is there enough evidence evidence at the 0.10 level of significance to conclude that an association exists. So we start off by writing our null and our alternate. The age of a person and level of educational attainment and favorite Super Bowl commercial are independent. So that's your null hypothesis. And then your alternate, simple enough. So those are the two things that we're trying to compare. Now we're looking for our chi-squared value. And you need to go over to edit, and I always keep it in the same matrix A. Now you need to know your rows. R comes first. So you have 4 rows, 2 columns. Always make sure you double check your numbers. So I'm going to go to stat, then test, chi-squared test. We leave everything like it is and then go to calculate. Chi-squared is 7.355. So our chi-squared test statistic, 7.355. Then we need our chi-squared critical value. Critical value is 6.251. Our test statistic is going up somewhere over here past that. That's in our rejection region. So we're going to reject that hoe. In the end, there is sufficient evidence to support the claim that there is an association between age of a person and level of educational attainment and their favorite Super Bowl commercial. So let's do the p-value method. So in this case, we knew that alpha was 0.10, and we have our p-value still on our calculator, 0.0614. 614 is less than 1,000, so the p is low, so you reject that hoe. So you're going to reject the null hypothesis in favor of your alternate hypothesis. What are the expected values? Now you can go over to edit, see it switch to B, and now you can copy all of your expected values. That's it for chi-squared test of association. So I hope you enjoyed this video. It was 2 examples, and if you don't remember the other tests that we have done, please check. It should be a link over here, and it should be a link over here. Thank you. Don't forget to subscribe to my channel. This is Professor Sampson from PS I Love Math, and I'm out of here.
Somewhere else, he'll find nothing. Just give it up. I'm not your girl, 'cause I only